Thank you very much. Poland is located far from Pamir Mountains, but as we already are here in Mexico, we can see pedologists are people who may make observation and research far from home. So also I was invited to Pamir Mountains, and I will not talk about generally characterize the soils of the area, because the topic of our session is talking about new contribution to soil classification. So I will concern on selected issues related to classification, making some problems. Just from specific area, Pamir Mountains, called sometimes roof of the world, located in most eastern Tajikistan, close to the Chinese and Kyrgyzstan border, already around the Kizilkum Lake, altitudes above 4,000 meters. Climate of this area, especially of this most eastern part of Pamir Mountains, is characterized in literature as cold ultracontinental climate, and the larger meteo existing for a longer time, located in close to the Karakul Lake at about 4,000 meters above sea level, indicates mean annual air temperature circa about -4, and mean annual precipitation only circa about 70 millimeters. So it is very, we can see, if we can compare with data, for example, here for Mexico, it is really dry, really cold. For our project, we created a provisional meteo station just for 1 or 2 years. Unfortunately, it is lost there. Located very close to the Oisu Glacier, so it is higher, located at 4,400 meters circa about, and the conditions are even worse, even harsher there. So mean annual temperature -7, mean annual soil or ground temperature at the depth of 50 centimeters minus circa about 1, so it is below 0. But we didn't find their permafrost down to at least 200 centimeters. And going to classifications, American classification of temperature regime, we can say it is gelic, and moisture regime aridic, if I properly understood the criteria. Naturally, the temperature is highly diversified through a year. There is a graphical indication of daily changes in temperatures, so it is going down even to -8 in summer, but no lower, and up to 10, 12 in the so-called summer. Okay, so this is characterization, but what is the topic of this presentation? If we look to soil classification, the indication of this harsh climate, specific environmental conditions in soil taxonomy are clear, because the moisture and temperature regime have direct imprint in soil name. But what about WRB, where we do not use directly the temperature and moisture regimes, but rather we look for soil features observable in the field, which should represent those specific conditions. So looking on the soils, watching the soils, and having knowledge about environment, do we have really specific representation of these conditions in WRB classification? Do it reflect the conditions and soil properties? A few words about environment. There are several places of study, so we don't have time, unfortunately, to talk about all interesting cases. I will talk only about 2 today. Oisu Glacier Valley, beautiful system of glacial fluvial terraces. We didn't make direct dating because there was it was not possible to do it, but from other similar works, we know that a similar system of end moraines here in violet, and various glacial fluvial terraces creates or covers entire Holocene period. So we may say the end moraines represents late Pleistocene or very early Holocene, and the next three levels of terraces represent various stages of Holocene. And our profiles were located, I will talk about profiles located only on terraces. Few pictures also from this area. So what is first the best visible? Generally lack of vegetation. Yes, so harsh climate. There is vegetation, we will talk about this, but very scarce. I will talk today only about the soils on the second, this medium terrace, because we don't have time. Each case is slightly different, but they are the most representative and probably the most interesting for this discussion. As I told, from relative dating, we can say that soils, that the area was developed 3,000-5,000 years ago, and yes, 3-4 times years ago, and no, sorry, before Christ. So it is plus 2,000. Sorry, I did not indicate this. So the period of soil formation is quite long, few thousand years. And please look the profile. No visible horizonation, very poorly developed a horizon, very poor marked change of color. In this soil, in soils of these terraces, as I told, we didn't recognize permafrost down to not only 2 meters, but even deeper. What we have, very high content of gravel, even up to 85% throughout the profile. Texture is sandy, sometimes sandy loamy, low electrical conductivity, or even very low electrical conductivity, very low saturation with sodium, high content of calcium carbonate, but really invisible, how to say, secondary accumulations. And the reaction of soil and comparison of soils at various terraces, even of very fresh materials, indicates our similar content of carbonates and similarly lacking secondary carbonates visible in any forms. And also, it is poorly vertically diversified if we are talking about the content of carbonates throughout the profile. Low gypsum content, much below our limits to indicate this as important feature. High pH, so neutral or rather alkaline, and base saturation naturally close or just 100%. Soil organic carbon very low. Even in the topsoil horizon, typically no higher than 0.2. Sometimes at the third terrace it was up to 1% when we had animals, but it was absolutely unique situation. And naturally decreasing with depth. What we have at the topsoil? We have pavement. We have beautiful pavement, but it is pavement of fluvial origin, and we cannot observe varnish as we expect in aridic environments, especially stable aridic environments, as you can see on the stones, his pebbles. No ventifacts. They clearly are originated from fluvial processes. But what is interesting, there is the thickness of this pavement is quite large. So there are 2 or 3 levels of stones. So if we compare this pavement with first terrace or fresh sediments, we can say that we can expect that some part of fine particles, sand or silt, was simply removed from the older terraces by aeolian processes. So we may say there are observable some how to say results of wind action, but negative, not positive, we can say, on these terraces. And what? And no carbonate cappings or any other visible accumulations on any side of the stones. What is also interesting at the topsoil, according to classification, naturally, surface horizons, the fine earth, the surface horizon directly below the pavement, have typically platey structures, sometimes thick plates, but sometimes it is unstable depending of the site, and beautifully developed vesicular structures. Here on this picture, maybe not visible. It is better visible in more silty soils when vesicles have even up to 6 millimeters of the diameter. So there are beautiful structures, and also other structures, we can say pseudomorph of ice needles from but there are pictures from other profiles, and according to classification of those soils. The first question is, do the soils have craic horizon? Yes, because we expect close to the glacier, but no permafrost. But as we remember, the definition of craic horizon allows us, the soils, recognizing craic without permafrost if we have temperature below 0. It is here, as I told, mean, not permanently, but mean temperature is below 0. But not enough water to create ice crystals. Yes, and the question is this, how to say, requirement met here? If we have moisture in summer, temperature above 0 and moisture 8 to 15%, and we have rooting throughout the soil down to at least 120 centimeters. It is not, how to say, continuous rooting, it is discrete rooting depending of the vegetation, especially there is, I am not specialist in vegetation, but Krashennikovia ceratoides is such species which has very deep going roots. So we have vegetation, we have activity, and in our opinion, enough water to develop. But so this is why we did not recognize here craic horizon. If we do not recognize craic horizon in such conditions, we have to go according to classification to leptosols, mostly to leptosols, due to the high content of skeleton throughout the profiles. And what we have in leptosols for such soils: calcaric, hyperskeletic leptosol, probably fluvic, but I am not sure of this fluvic on very old terraces. We discussed this several times also in Mongolia. Gelic, yes, ocric, and at the moment we would like to add yermic, but we don't have probably aridic properties, so yermic is also questionable, even if, as I told, the structures are beautifully developed here. So what we can say: too dry, too cold for clear development of horizons, too dry for secondary salts, carbonates, gypsum accumulations. But where are the indicators of these extreme environments? Hidden somewhere in supplementary qualifiers only, and even questionable. So my suggestion here is just to push the most important qualifiers, at least in poorly developed soil reference groups, such like leptosols or arenosols, regosols, to primary qualifiers. And what was discussed also, to change definition to disrupt the connection between aridic and yermic and other, to allow yermic recognition even if aridic is not allowed. The other question is, should such soils be classified as leptosol really, or maybe to regosols if they don't have hard rock? It is another question. And a few words about the second case. 50 kilometers away, close to Karakul Lake, beautifully developed Holocene terraces close to the lake, and a few meters higher Pleistocene terraces with a very common thermokarst phenomena, both as sliding and also creating of small ponds, lakes, because we can observe in these tertiary Pleistocene terraces, we can observe beautiful permafrost at the depth even 70-80 centimeters. Naturally, it is not visible here in colors, but maybe on the right picture it is visible that it is, how to say, hard surface. It was cut as in ice containing some mineral soil. What is interesting in these soils? In this soil, permafrost at 70, 80 centimeters, turbation, cryoturbation, rather poor development of horizons, but distinct accumulation of organic matter and beautifully developed crusts at the surface. Few words about chemistry of this soil. So what we have here, pH very high, maybe not very high, but higher than typically than 8.5, high concentration of carbonates, and in those soils, secondary carbonates were rather visible, but as very small accumulations, and also the difference in carbonate content allows us, according to our rules, to distinguish, to recognize calcic horizon. What is interesting here, electrical conductivity, which is quite high, but not enough high in upper mineral horizons if we do not take into account the crust to recognize salic horizon. Yes, so I am very happy with new proposals coming from Peter, from various discussions, to involve also crust, because it is specific situation. Do we have thick, beautifully crust and vegetation typical for saline soils, and we cannot recognize salic horizon? Yes, so inclusion of salic allows us to recognize salic, but we have to clarify the technique of calculation, how to calculate this, how to say this result of how to say thickness and the content of saline electrical conductivity. Also quite low, maybe not quite low content of gypsum, but accumulated only in the very topsoil horizon and in the crust. Among anions, as you can see, dominating sulfides, chloride, not so many. So the question how to classify this beautiful soil with permafrost, naturally it is cryosol, naturally it is turbic, reductiaquic. We will not discuss this qualifier. It is calcic, as I told. At the moment, as I told us, also we cannot say it is salic. At the moment, also we cannot say it has any crust at the surface, yes, because it was not allowed in cryosols. So the research from Pamir mountains, from these extreme environments, indicates us that it is absolutely possible combinations of cryosols and saline, various kinds of saline soils with all features of saline soils, including crusts, yes? And as I told, it is very close to be both calcic, salic, to have both calcic, salic, and very close, but it is not met here, to gypsic also. So what is also our suggestion to the next classification, just to allow in cryosols indication of such properties. So the conclusion, I already said that the classifications work very well, even in such extreme environments, but at the moment, there are some lacking qualifiers, lacking characteristics to properly, how to say, show the important ecological properties of those soils. We discussed here that we should merge processes, characteristics, and also ecological functions or productivity of soils. And in this case, those qualifiers are important. I am very happy that many of our findings here are already under discussion to the next version, and I hope they will be introduced. Some of the data were published, but only parts, because during of our questions, we, how to say, waited for some changes to publish in a new version with new names. Thank you very much for your attention.
Thank you, Cesary, for your interesting excursion to Tajikistan, your very informative excursion to Tajikistan. We have a little bit time, 2 minutes for questions and comments, please. Who wants? Yeah, please.
some fluvial surfaces did not. I think it's well heard. Better in this way. You mentioned that in some younger fluvial surfaces with stone pavement, you did not observe desert varnish. However, I suppose that on the older surfaces and some rock outcrops, you saw this feature because it is typical surface feature, geological surface feature of this region. Then the questions are, first, do you consider this neoformation as a pedogenetic object? And second, if yes, do you see some chance to include it in the classification definition?
Thank you. Thank you. The last question, the last answer. In fact, partly it is already included because in aridic qualifier we included